My project was about projectile motion and how the wind affects a projectile motion. So what is projectile motion? It is, simply put, the motion of an object when it is thrown or launched into the air. So when it's being affected by some sort of force that is launching it through the air and, of course, eventually hitting a target. Wind is the movement of that air. And the goal of this experiment was to test how does the wind or the movement of the air affect the projectile that is in that air. So for my experiment, I first started with this ball. It's a 3D printed ball. It's about 65 millimeters by 65 millimeters, weighs about 50 grams, and it includes a battery that I took from a drone, a microcontroller, and an accelerometer. The accelerometer is measuring the X, Y, and Z acceleration of the ball. This is used, of course, to see if the wind actually does make an effect on the object while it is in motion.
On a side note, ignore the odd orientation of the videos as that was related to the way I recorded them.
As you can see here, for these trials, what basically happens is the ball is launched up, and the first three were without any wind. The next three were with low setting on the wind. So on the fan I was using, I had four settings: no wind, low wind, medium wind, and high wind. So I was able to use this in order to see if there were any differences between the different amounts of wind. Another note here, one of the main issues I had was with the spring being inconsistent. So the two springs are actually rated to be the same exact strength, but in practice they're both slightly different from each other, which causes the launches to go slightly different. As you could see from the trials, some of them went to the left, some of them went to the right, which of course is not great when we're looking for consistency's sake. What does this all mean? Here we have three graphs: the x acceleration, the y acceleration, and the z acceleration. And here was the main issue that I ran into. When you take a look at the graphs of the data, you can't tell a lot. But what you can tell, of course, is where each launch took place and the displacement between the starting acceleration and the final acceleration. And the main thing that you notice there is that they all are similar. Of course, there's going to be differences because every single launch was slightly different. Some of them come from above the axis down to the middle. Some of them come from below the axis up to the middle. That has to do with, first, the sensor not being correctly calibrated, and second, the angle of the accelerometer changing. So when it would be flying through the air, the projectile wouldn't just stay linearly or in the same plane. It would rotate. And the issue was I couldn't take that rotation into account for this acceleration. So what does this data show? Well, all this data shows is that if wind did have an effect during these trials, it was marginal. But that doesn't mean wind does not have an effect. One of the things that could have made this experiment better was if there was a higher source of wind. If the projectile was lighter, there was most certainly an effect that could be seen, because the wind is going to have an effect on the projectile in motion because it is acting like a force. Because the projectile is moving through the air, so that movement of the air is going to affect how the projectile itself moves. And this ties, of course, into external forces that can act on your projectile. When your projectile is in motion, of course, the gravity is pulling it down, and initially the launching force has affected its motion. But after that, besides external forces, there is most likely nothing internally affecting it. So external forces could include, of course, the wind, or maybe it hit another object midair. That is certainly going to change its path of travel. It could actually be a factor of drag. So how the wind is coming across the projectile will affect how the projectile moves. Therefore, while wind does have an effect, it cannot be seen in this based on my testing mechanism.